Alright guys, today I found another book in newCTFE, and let me show you what this is about. It's about this. This is originally a test to check if delegates work, but I found out that this check failed, and what it does is it creates a struct with default values, which is also kind of sketchy, but it works right now. Then it basically has a loop which is terminated when this fails, and this relies on this continue actually working. Now, if we take a look at the IR that's generated, if it's still in the paste buffer, yes, then we have to check at which line this continue would be. I think it's 35. Yes, 35. So since we output line information, all we have to do is check for line 35. Here it is, and there we do a jump, as we would expect. We generate a label, and the label is generated at the point where we currently are. So this puts a label at the end of the loop. Right, then we start another jump. We generate another label, and we fix that jump up to the label at the end of the loop, and we fix the other jump to the same label at the end of the loop. So first let's look at what we should do. So we should all be able to see that this code is completely bogus. What it does is go to L, then it does L, well, actually what it does is this, because here are two unconditional jumps, right? This is what happens. You have two go-tos to the line afterwards. That's it. That's all that's happening here. So in order to debug what's going on there, we need to see from where the begin jumps and the gen labels are created, which means we need to take a look at that, and I think gen label, yeah, if we set debug label location, we should be able to see where this is generated. So label location, there it is. We enable this debug variable, we recompile, and now we should see, if we run the compiler again, for line, what was it, 35? We now see in a comment from where the gen label was called. And the first gen label is called from 4410, which I assume is the place where we actually treat the continue of a while loop. Yes. Okay. This happens when we generate a block, right? And I assume that should be one where we have a custom break continue, because I'm pretty sure, I mean, the continue will fix this loop up to the begin, right? The result begin will be the label that was generated when we accepted the statement. However, what we can see here, oh yeah, this was the end. The end label is generated here. The begin label is generated in 448. So actually, if we check this, we should see a gen label from 448 in line 19. And if we check line 19 with currently failing, we will see that this is the beginning of the while loop, which actually is where the start should be. Alright? Now, we see that if there are no, if set current is true and there are no custom fix-ups, then what will happen is that the old continue fix up, so that the fix up continue is called to results begin, which would fix up, which would fix us up to the right continue, to the right label. So what we now need to see is where this one is being called. So we do line, doesn't really matter, and then we do we put a comment gen block card from empty string of the line number. I think that should help, because then we will see where this is actually being called. Okay, this is quite interesting. There is one block, gen block, which gets called from 4467. And another one that gets called from 8502. And what we can see here is that there is a gen label called from 8504, and the only reason they get fixed up to the same label is because there was no instruction emitted between the gen label, the last gen label call, and the other one. So what will happen is when you do L2 colon L3 colon go to L3, this will automatically be fixed up to L2 and L3 goes away, because we know that there's no interceding instruction. So that's why you see this auto label, gen label commented out, and the end jump here being fixed up to the same label as this one. So we see that there is an end conditional jump here. The end conditional jump is something that is dependent on conditional jump. What? Okay, sorry for that interruption. Let's hope we can edit that out. Where was I? Right. When we get here, we set another to 0. However, if we jump to label 18 or label 19, that doesn't happen. So we have a conditional jump 6 and a conditional jump 5, and the conditional jump 5 should be the one that's responsible for jumping on the variable another. And that is true. So the conditional jump 5 jumps on the variable another. If that variable is 0, the jump to label 19 will happen, which will fall through to the return. And if that is non-zero, the jump to label 9 should happen. Let's see where label 9 leads us. I would say label 9 should be right before the check, and that's true. label 9 is here. It's generated from 4455, which I guess would be in the while loop handling. Let's check that. Wrong file. Yeah, this is for the for loop condition eval. I think we should do a fix up continue. But there's only a fixed up break. After the increment, we have a jump to condition eval. And if there is no increment, we simply don't do the increment and we have a jump to condition eval. That actually looks like that should be correct. So we definitely have a gen level here. We definitely jump to it. And we jump to condition eval unconditionally. Because the conditional jump is fixed up after here. Right, the problem is here. The problem is to fix up continue. The continue is fixed up to the end of the function body. And after the end of the function body, there should be an unconditional jump to the condition eval. However, if that does not happen, we jump to the beginning of the body. Which will not evaluate the condition properly. So I think all we have to do is this. We need to fix up continuous even if there is no increment, because while loops get lowered to for loops with no increment. So if I am correct about this, then this change should fix the currently failing set, and we see that it does. So again, this was the state before. And when we do this, but what? Right. Because we currently have the printer backend, nothing we do will actually change. The code execution. So let me remove the printer backend from here. And now we see static assert, which shows us that this one is not the expected value. So now we would expect that if we have indeed found the bug, if we put this fix up continue out of being predicated on the increment, we should indeed compile correctly. And we see that we do. The static assert is no longer failing. Alright, that's it.